Welcome everyone. This is Karen Leon and I will be presenting the implementation of Prisons VR in Algebra 1 class for ninth graders. Today I will be presenting an initiative for the math department that will not only improve student scores, but also get them enthusiastic about it by connecting it to the real world through technology. The question is, how can our educators teach abstract math for the real world to our students? The mission of our School of Architecture is to prepare students with specialized skills to shape their physical environments. But there is a massive disconnect happening. Our students want to become architects and interior designers, and they need to understand scale, rate, structure, and strength to actually build things. However, students have difficulty understanding Algebra 1 when taught in a traditional way, and it feels entirely disconnected from their career goals. Last school year, 91.5% of our ninth graders did not meet the NJ Math reasoning standards. Many students can solve an equation but struggle to explain what the quantities mean in a realistic situation. None of the bilingual students or students with special needs met the expectations in these areas, creating a critical gap that demands immediate and targeted intervention. So, how do we even begin to fix that? To address this, we are implementing PRISM's virtual reality activities into our Algebra 1 classrooms. Research shows that reality enhancing technologies can help students bring math to life by enabling them to visualize objects in 3D and discover algebraic relationships through movement. Students will study real life scenarios through their headsets before studying with technical terms like combining letters and numbers, that is very common in Algebra 1. Now, success depends on pedagogy, not just equipment. For this reason, our two Algebra 1 teachers will undergo instructional training and technical readiness checks. Starting this October 2026, they will implement at least one standards aligned VR lesson cycle each month. And we are prioritizing support through the weekly PLC time, coaching, and collaborative lesson planning. Again, our goal is to expose our students to a clear understanding of what is the connection between abstract algebra 1 and real world situations. Instead of staring, for example, at a flat graph on paper, students will wear the headsets to build and manipulate math concepts in 3 dimensions. They get to see the real life application of algebra. This project connects to 7 NELP standards in practical ways. Standard 1 is reflected in how the project supports the school mission by connecting Algebra 1 to architecture, design, and real life problem solving. Standard 2 guide us to be transparent with families and make fair, responsible decisions about how students use the technology. Through Standard 3, bilingual students and students with special needs will receive the language supports, scaffolds, and alternative they need to participate fully. And Standard 4 is the heart of the project because teachers will use coaching, lesson reviews, student work, and assessment results to improve the instruction. Standard 5 reminds us that families and community partners should be involved. Standard 6 focuses on the planning behind the project, including scheduling, technical support, headset safety, sanitation, storage, and responsible use of resources. Finally, Standard 7 addresses hands on professional learning, collaborative planning, coaching, and reflection, which will help teachers build the confidence and skills needs to use Prism VR effectively. The integration of virtual reality technology is for a cohort of 240 incoming freshmen, facilitated by two Algebra 1 teachers. To meet the goal, 8 specific objectives were established to ensure our success. Teachers will get training and meet at least 80% of the checklist items in September. Students will take a diagnostic test that is aligned with the NJ standards and will be informed of their grade by October 15th. With this baseline in place, math standards will be prioritized. Before the holiday recess in December, students will demonstrate connections to real life situations by achieving a 50% increase. And by the end of February, 65% of students will meet the established proficiency level on common end of unit assessments with an increase of 10% or more for pre and post assessments. By March 31st, the expectations is that 70% will independently apply Algebra 1 concept to unfamiliar real life situations and justify their answers at a proficiency level as defined by the rubric. At the end of April, the team will complete a final evaluation using all the collected data and recommend whether the implementation was successful and whether to maintain it or perhaps adjust it. We are very committed to equity. Every multilingual learner will receive language support, and all students with disabilities will have access to materials that meet their needs. Families will be kept informed through PTO demonstrations and clear communication in multiple languages regarding student safety and instructional goals. And for those students who cannot use headsets, an equivalent non headset option will always be available. To provide a clear picture of how progress will unfold throughout the initiative, the first month is about setting up a solid foundation, getting baseline data, training our teachers, and selecting the right modules. From the second to the fifth month, evidence will be collected through VR lesson cycles while continuing to coach, plan, and review students' data. Then, after a major midpoint review in month 6 and any needed instructional adjustments, the final 2 months will focus on comparing the updated data to the baseline, culminating in the final report. With the support of our principal, I will lead and coordinate the initiative, submit the reports, and coach our two teachers. One teacher started last school year, and we have a new team member this year that is new to the district. Both teachers will collaborate to strategically use pedagogy to merge traditional teaching with the virtual reality technology. We will also reach out to other faculty members and staff for interdisciplinary support. Alongside the presence VR technology, teachers will have ongoing instructional coaching and dependable technical support to help them feel confident and supported. The math department will use its weekly PLC time to plan together, look closely at students' learning, and make thoughtful adjustments to instruction. Each month, students will engage in Prison's VR lesson cycles across three 40-minute classes, giving them time to explore, practice, and reflect. We will also ensure headsets are stored safely, that wireless access is strong and reliable, and the staff has everything they need to clean and sanitize devices after each use. The use of VR technology in this project is grounded in a range of studies. Current research in math education shows that virtual reality can transform how students experience mathematics. For example, Washington et al., Simonetti, and Su describe how VR allows learners to engage with math as it exists in the real world through visualization, movement, and hands on exploration. Buentello Montoya et al. Also note that when teachers integrate technology naturally into their daily instruction, it helps students make sense of mathematical ideas more deeply and support stronger learning outcomes. Blackstein also reminds us that meaningful, sustained improvement doesn't always come from technology. It grows from a community working together, a shared purpose, and embracing collective responsibility for student success. When VR is paired with a culture where educators collaborate, support one another, and stay centered on students, learners benefit from deeper understanding, stronger engagement, and long term growth. As mentioned earlier, the instructional approach and coaching model is built around three connected parts that support both teachers and students. The first part centers on VR lesson cycles. The second part focuses on assessments and analysis, giving teachers time to look closely at student thinking, identify patterns, and reflect on what students need next. The third part involves coaching and instructional adjustments, where teachers receive support try new strategies, and refine their practice based on what they learn from students' data and classroom experiences. Together, these three components create a steady cycle of learning, reflection, and growth for teachers and students. So, what will be provided during the VR implementation? It will have a clear set of deliverables, including an implementation plan and timeline, coaching schedules and PD sessions, student work samples with assessment comparisons, a midpoint progress summary, and a final report with recommendations for continuing VR in math instruction. Together, these pieces show how the school is learning, adapting, and supporting students through immersive technology. Some strategies will support equity and inclusion, such as language scaffolds and multilingual materials, intentional grouping, extended processing time, alternative ways for students to participate, targeted support for bilingual learners and students with special needs, and family communication in multiple languages. All these components will ensure our students' success. To support students at home, PTO meetings will include hands-on VR demonstrations so families can see what their children are experiencing in math class. Updates will be shared through emails along with visual progress reports that make students grow easy to follow. And families will also receive a short survey to share their input and ideas, ensuring their voices remain part of the work. Our first steps in September focus on getting everyone grounded and ready for the work ahead. We'll finalize fall enrollment demographics, set clear growth targets, share information with families so they know what to expect, provide training to help teachers feel comfortable and prepared, and administer the diagnostic assessment to establish a baseline for student learning. These action steps help create a shared starting point for all of us in this new school year's project. These references were used throughout the initiative, and they are available for anyone who wants to learn more about the ideas behind the work. They offer helpful context, clear explanations, and a welcoming way for families, teachers, and staff to explore the research behind my approach. Thank you for your attention, and I will be available if you have any questions.